regression of our last data set, this one right here, we've got to do nonlinear regression. So this is the function that we use to generate the data set. And I want to draw your attention to C1. So notice that C1 is inside the exponential. It's also in the denominator under x. And therefore F3 does not depend linearly on C1. That is why we have to use nonlinear regression. We had discussed the Gauss-Newton procedure in which we guess parameters, in this case C0 and C1, and we have to calculate a refinement of that guess using this formula. So you have to calculate your Z matrices. They look similar to linear regression, except you have to recalculate them for every iteration. And then you have a D matrix, which is a column of differences or error terms, differences between predicted and measured values. So we do an iterative procedure in which you guess, refine, check how much your guess has changed, and then repeat as you see fit. Okay, so we're going to now do nonlinear regression, power law data. And I'm going to build everything around this update function. So what I'm going to call C guess is going to be a column of guesses for our C parameters. And it's going to be related to this Z transpose Z times Z transpose D. And I've got to define Z and as well as D. So because I have to do this for each iteration, I'm going to define Z as a function. Okay, so I'm going to say Z sub j to make it clear that it's a specific iteration. I'm going to need my X data, and I'm going to need my C guess. Let me put the Z formula on the screen so you can see what I'm doing. That's this. It's going to be an anonymous function, and it's going to be a matrix. And I'm going to need to calculate, I'm going to define more functions, df, da0, I guess c0, and this is going to be x series, and then c guess, and then this is going to be df, dc1, X series, C guess. What did I just do? And then I need to transpose this whole thing to create columns out of the rows. And I also need to find dj, so I'm going to define my derivative functions in a minute. But dj at, so dj is going to depend on X series and the Y data, and then the C guess. And it's going to be Y series minus f of X series is a function you're trying to fit. Why does that keep happening? That needs to be a column vector, so I'm going to make it into a row and then do a transpose. So in order for these to work, I need to define f dfdc0 and dfdc1. So let me start with f. Sorry, f doesn't have to be a series. C guess. And this is going to equal so C guess times exp x over C guess of the other parameters. Okay, so remember our formula here is this. So we need to know how the derivatives look. And if you don't really want to calculate derivatives, you can go to Wolfram Alpha. Okay, so I regularly use Mathematica, so I tend to prefer putting in Mathematica commands. So that's the derivative with respect to C0. You'll see it's just e to the x over C1. And then if I take the derivative with respect to C1, it's more complicated. That's this expression. So I don't need to copy it because I have it in my notes. So I'm going to define df dc0 and that is going to equal exp of x over c guess 2, 1 df dc1 equals at x guess or x c guess, and that's going to be minus c guess 1 times x divided by c guess 2 1 squared times, oh wait, inside the parentheses, or that looks right, exp x let's take a look. See if I type those reasonably well. Okay, so this is going to be the first parameter with a negative sign times x over that should be a times. So e to the x over c1, and then in the denominator c1 squared. Okay, that looks all right. c0 times x. I suppose I could move this in order to make it conform a little better to what Wolfram Alpha is showing. Yeah, that looks okay to me. Okay, so now I think we've defined what we need to actually make z, j, and dj work. So let's just do one iteration. So I'm going to say cguess equals, I'm just going to give it 1, 1 as an initial guess. So let's run it and see if I made errors. Looks like I did. Line 95. Oh, this should be y series. Y series minus f of x series c guess. Seems unhappy with something. Oh yeah, missing the close parentheses. Okay. Oh, I did not define D. Actually, I didn't define Z either. Let's just say that Z equals ZJ, X series, C guess, and D is DJ. Let's take the semicolons off just so that we can check the dimensions of the matrices. Okay, so Z has 2 columns. There are 2 fitted parameters. Maybe that's okay. And D is only a single column. Looks like it did the calculation. So let's do some more iterations. Okay, so I need to put this into a loop. So what I'm going to do is I'm going to say I have a maximum error. By the way, normally I would put this into a separate MATLAB function. But for illustrative purposes, I'll just do this in a script, and I'll do a while EA is greater than EA max. And now I can do my guessing. Fendi, stop it. Fendi, stop. My dog again. Okay, so now I have to estimate error by just saying the largest change in C guess new minus C guess, and I want to scale that to C guess, and also take the absolute value. Largest component in the percent relative change. Should probably multiply by 100. Not that it matters, but I'm putting it inside the max function call. I think that's right. So now, in order to continue to do loops, I need to now say cguess equals cguess new, discard the old guess, z equals, I need these lines again. Need to reevaluate z and d. Okay, so now let's look at cguess at the end. Okay, so it did converge on something. about 3 and 2 as we did before. Let's take a look, C0 and C1. Okay, yeah, in the ballpark, especially for the C1 term, so maybe it worked. Let's now plot the answer. I'll remember to do the hold on this time. Three, 1, 3, hold on, and actually, why don't I just do F? Why am I retyping all this? F of X series C guess, and now I can say a plot Okay, looks like it worked. Now, I don't know how carefully you're looking at this, but this curve's a little jagged, right? That's because the points I'm plotting for the best fit curve are spaced equally to the data. This should also be jagged. It's a little harder for me to see, but let's increase the fineness of it. So instead of just using X series, what I'm going to do is I'm going to make an X series finer. Should I do that? Let me do it up here for the quadratic. Just a finer step. And I'll use that instead of X series. And I'll do that here too. You may not care so much, but was there an error or is it just still running? Looks like it didn't plot. Whoops, that's supposed to go to 10, not 1. It didn't plot all the way to the end. Okay, so now the best fit curve looks smoother. Very good. Thank you for listening.